Hello and welcome to this webinar about construction stages. Me who is presenting today is Fredrik Lagerström, and I am the product owner of Prestress, and I'm also in the technical support of Winsateak and FEM-Design. Today we are using GoToWebinar, so you are free to ask questions in the window, and they will be answered after the webinar. There is a function for raising a hand, but I will not be able to manage that during this presentation. So it's better to ask the questions directly. And the presentation will be made public on the Strusoft YouTube channel later today or tomorrow. The questions and answers session will be cut away from the final video, so you may ask any questions that you like, and they will not be presented there. So no shame in asking any questions at all. Today we are going to look on these construction stages and where we can find it in FEM-Design, both in the structure and the loads tab. And then there will be a live demonstration and then the questions and answers session. In the structure tab, it is possible to find the construction stages, and that looks like a semi-complete building, and that is the rightmost command in the structure tab. In the very right end, you have the prefab print and the documentation module, but for the structure specific commands, it is on the rightmost command. While in the loads tab, it's very early in the beginning, just before the loads groups and load combinations, and by this selector of the load cases. The model needs some settings to be made, even though that we introduced this function in version 17, where you had to have stories. Then in version 18, it's possible now to have an arbitrary number of stages, and you can assign any structural elements to any stage. For simple generating the construction stages, you just operate the generate by stories, and you will get an initial state where you can have the ground floor or the foundation slab and up to the roof. And then it is possible to just enter more stages afterwards. So here I have the initial building with the 7 stories and the elevator top. And then I've added 2 more parts of the structures that they will be building. It's also important to enable the initial state, and that is done by the X in the last column here. And the next state is still in the structure tab. And here we will be assigning the elements to each construction stage. And it's easiest to build the complete structure that we can see here on the picture, and then you just assign basically backwards that the last stage will have the last stage elements, and then you move backwards in order to see what elements you have left until you reach the start of the construction, and then you just basically have the foundation left to assign. Here we can see that I have come maybe halfway. I have assigned the right part and are currently assigning the middle part here. And what you do is that you view the part that you want to reassign these elements for. So here it is basically the walls in the elevator shaft, and the hollow cores, the beams, and the columns. And if you've done it correctly, it's possible to then view the construction stage sequence. And by pressing the little film here, it's possible to then see that this is the way it will be built. So here it's also good to see that in order to build the structure, it needs columns and beams and then the plates. So each stage is basically one story that will be built. It is possible to color code the construction stages as well. This looks a little bit confusing, but for smaller structures or that doesn't have these many parts, it's possible to then see the color code of each stage, so you can follow it from top to bottom here, that the ground floor, and then the story 2, story 3, story 4, etc., etc. So when we are moving away from the structure and moving into the loads, it's possible to add the loads. So you have the load cases defined, and then you basically just define that from what load case will I get the stage. So here we see that in the ground floor, which is my initial state, I will activate the dead load, and this will act from this stage on. And by the time they come to story 5, then here I have said that they start with the outer walls and that it's shifted from the first stage, which basically means that here, when they start story 5, they will add the outer walls of story 1. And the timeline is shown here on the right. So here you have the dead load for the first stage and the dead load of the second stage, and so on, the third part, fourth part, fifth part. And when you come to assembling the fifth part, they will start adding the loads from outer walls that are acting on the first part. So it is shifted 5 parts earlier. And then we see that in the when we are placing story 6 here, the 6th part, then the outer walls start with their second part. So that is always in the same time difference onwards here. And when we come to the final stage, then all the last parts of the outer walls will catch up. It is possible to also define that it's one load should be acting on a certain stage, or that it's only acting on the stage activated elements in that stage. So here we can see that we start with a dead load. The factor here should be the factor used in the calculation. I've just added one here for simplifications. We can see that the outer walls are shifted from the first stage. And when we take a look here in the third part of the structure, we basically say that the live load will be acting on the structure here from this stage on. And when the building is complete, we will be adding the snow loads, the wind loads, and so on. There are two calculations being performed, or that can be performed, and the user should select. There is one called incremental tracking method, and that is basically that the structure is being built up part by part, and the deflections will be the sum of each part, or the addition of each part here. While in the ghost structure method, the whole structure is actually being built, but the stiffness is set to 0. So there is a small difference for this kind of method. But to me, the most logical would be the tracking method, because that is when you apply the different loads in different stages. But both are viable. And for the results, it is possible to see the reaction forces, for instance, and you basically just enable the result construction stages. And here for the reaction results, we can see the reactions for each stage. So when we come up to the part 3 of the structure that we can see here in the picture, we get the different reaction forces acting at that time. And the reaction forces is not the only one. What you can see are basically all the different kinds of results here. So displacements, reactions, internal forces of both bars and shells, and the stresses as well. It is also possible for the bar forces to get the detailed result, and then it's possible to basically select what story and what stage you want to look at, and you can get the forces in that stage. And if the beam, or the column in this case, would be placed at a later stage, then in the earlier stages it will be set to 0, because it is not placed at that point. So there will be no results shown in the detailed result. I will now present the function, and I will do that basically by doing 2 different models. The initial model that I will be showing is a very simple frame, and a good way to look at this kind of feature is to make a small test first and familiarize yourself with the function instead of just starting it on the biggest building that you have. So I will here define 2 frames, and I have defined 2 stories. So it's a quite small frame, but I will have the 2 stories made here. I have defined 2 axes that I will be placing my frames in. So I will be building the whole structures first. So I will be placing the columns, and then I will be placing the beams. And here we see 2 identical frames, but I will handle them differently. So in the construction stage, I will say generate by stories, and this will create 2 different stages, basically, where the first story, which is the initial columns, and the first story of beams will be placed, and in story 2, the next on top here will be placed. But I will be creating more stages here. So I will be placing a column, this column afterwards, and then I will be placing this column. So first I will be having this frame built up, and then I will just add the columns. And for the second one, I will just be placing the whole frame at the same time, basically just showing what the program is calculating without the construction stages. If we would have more elements introduced or placed in the model, they will be automatically placed in the or auto-assigned to stories as shown down here. And here I will see the different stages, and here I will have the frame 2, and I will be assigning it, and here I can box select them, and this means that when I now view the previous stage just before, then that will be not in the model, so I will only have the first one here. And for this part, I will now reassign the upper column. And if we go back one state, we can see that it is not placed. So this is basically how the structure is being built. I will have this column, and then I will have the story 2 and story 1. So by animating the result, this is how it will be built or handled in the program. I will, of course, have some supports as well. So I will be placing the point support groups in the bottom here, and it needs to be fixed in order to get the structure to be stable. The loads I will be having are the dead load. It's just a dead load acting on the beams, but it's also the structural dead load of the elements. And then I have a live load that is just an ordinary live load. And both are 10 kilonewton per meter. If I now go in here into the construction stages, I can basically say at what stage the load will be activated. So here I will be starting the dead load, and that will have a factor of 1.35. And it should start from this stage on. And I will be applying a live load here in the later stages. And that will be shifted from the first stage, which basically see that we can have the dead load in the first state, the second, the third, and when we are placing the second column, we will apply the live load on the first state only, or the first part here that we created. And then for the when we apply the second frame, we will basically apply the live load everywhere else. And this means that for the second frame, we will have that frame and the load applied at the same time. Basically, that you do when you're modeling without the construction stages. I am going into the analysis part, and I will be showing the construction stages, and I will be using the tracking method here. So I will be enabling the construction stages. Note here that the program is calculating each stage here by itself. So it basically just adds the element for each stage. And for the final stage here, there was quite a big increase in the number of equations. And this is due to I added the whole second frame here compared to the others where I just increased by a few elements. So I will be switching over to the results of the construction stages. And just to show the moment forces here, we can show in different stages. So when I have the first stage and I've applied the loads, it will be looking like this. And then we will be showing the next stage with the loads that are activated. When I am now adding the next column, in this part, it will just be basically be placed under the beam. There will be no change in the moment distribution because this beam and this structure already has its load taken down in a certain way. So in this case, the column is just placed under the beam. And for the next state, there will be the next column, but here I've added the live loads as well. So we can see that there is now a bit of a positive moment due to this load, but the main part of the dead load is still acting the way it is. So it's only the load added on that will have this small change in the moment curve here. And since I just placed this column here, then there will be no positive moment here for this beam. And here I find it quite interesting to see that there are differences where I add the loads and so on, compared to the second structure where I don't have the possibility to use the construction stages. And here I will have much larger moments, for instance. And this is just because I've placed the whole structure and I added all the loads at the same time without the different stages acting on the structure. It's also possible to look at the reactions, and here it is possible to also see the differences that we have in the reactions. And there's quite a big difference here in the support reactions. Just because of the redistribution of loads acting on how I set it up. If we are going to take a look at a little bit bigger model, I will not save that one. Then it is basically the big model of the building that we saw in the presentation. And I will show the different results acting on this model in different stages. So we can see here that when I have the ground floor, then I get some results basically acting on that structure. And when I've now applied the first structure here, where they will be placing the walls and the hollow core plates, the beams and the columns and so on, there will be a distribution of the loads that will be acting differently compared to the if we just placed or built the whole structure and just made a load takedown from that. So here it's possible to see how the different loads or support reactions actually increase for the different stages. So here we can see the support reactions acting on the first and the second and the third, and that there are no actual redistribution of the loads when building the last part over here, acting on the first part here. And this type of structures being built like this, it's giving much better results. Otherwise, there will be redistribution of the loads, and there might actually be tension in some columns here, just because how the loads are carrying down when we are just applying all the loads at the same time, compared to when we start to divide the structure up. In the structure that I've had here, I have the snow loads, outer walls, live loads, and dead loads as shown in the presentation. And I have added them in this part, but it's also possible to move them around or not having the live load start until the actual building is being built here. But there might be loads acting on the structure in a certain stage that they might be placing a lot of gypsum or something like that on the floor during the construction, and you want to see how that is being able to be handled. And as for the structure, if we take a look at the construction stages, I have generated the first, I think it was 7 stories, and then I just added the elevator top, and then I added this manually afterwards. And this was basically the quick tutorial about the construction stages, and I would heartily recommend to use it. It is in the program. There is no extra license needed for this to be used. It is just up to you and discover how to use it for your structures. But you may use this short guide as well to see how you want to set it up in your structure. And as always, just make a quick test first, and rather than to just apply it on the whole structure in the first place, make a small element or just the small 2 frames that I've shown, just to verify and see what happens if, and apply the loads differently to see what is happening there. And as we could see with the live loads, that I got a little bit of a positive moment, but if I would have just applied the loads on the structure when it's fully built, which is not really the way it's done in the real world, as the dead load of the elements will be added on for each story built or for each part of the structure built. I will end this session here, and there will be more FEM-Design highlights in the future, and the next will be regarding the foundation design. I have not decided on the date yet, but it will be in mid-October or early November, as my schedule has cleared up, and we will be informing you and everyone else on our social media channels. So thank you from me, and I will see you next time.